So good afternoon. This is another lecture video. This time we will be discussing alcohols, phenols, and ethers. So here are our learning objectives. So first we will name alcohols, phenols, and ethers. Second, we will describe the properties of alcohols and ethers. And number three, we will try to identify phenols and their uses. So to start, alcohols, phenols, and also ethers are considered as organic derivatives of water. So bakit siya naging organic derivatives of water? So we start with the structure of your water. So we know water is H2O, and in um, molecular geometry, it's HOH. So the oxygen is in the middle and it is bonded to two hydrogen atoms. Now, paano siya naging organic, yung ating alcohols and phenols, paano naging organic derivatives of this uh, water? So imagine this, where's the cursor? This H, we replace this with a C, with a carbon. So we have here the functional group OH. And this functional group OH is for your alcohols. So any organic compounds that end with OH, that is considered as an alcohol. Now, paano naman yung sa phenols? So imagine this H here is replaced by we attach there a benzene ring. So upon attachment of your benzene ring here, this will become a benzene ring with a OH. And in our previous discussion, that compound is called a phenol. So it's an aromatic compound with an OH. So it is also um, it's same family, magkakapamilya sila dahil sila ay may OH. Now, how about if we replace the other hydrogen on the other side of the water? We replace it with another C. So this time we have uh, two carbons, and in the middle of the two carbons you have an oxygen. So and these carbons pwede yan lengthen. Ibig sabihin hahaba yan. So pag humaba yan, you have here a functional group na yung R is in R, and another R in the middle of the two R's here are yung ating oxygen. So the functional group is ROR, and we call that your ethers. So these are the general structures of your alcohol. So it's a C with an OH bonded to it. Now, your phenol is just a benzene ring with an OH. And last time na-discuss ko ito in the discussion of alkenes and alkynes sa reaction, yung tinatawag nating enol. Keto-enol tautomerism. Doon sa enol, bakit siya naging enol? Meron kang alkene at meron kang alcohol component. So, in short, that's called an enol. So, just to describe, alcohols are compound that has an OH group bonded to a saturated alkane-like carbon atom. While your phenol, it is a compound that also has an OH group, but it is directly bonded to an aromatic benzene-like ring. Next is an ether. So ether is a compound that has an oxygen atom that is bonded to two organic groups represented by ROR. So here are some examples of your alcohols, phenols, and your ethers. So we have here this compound ends with an OH. So we will name this as your ethyl alcohol. Ito yung ginagamit natin pang disinfect ngayon dahil may pandemya. Now we have here a phenol. So we have an aromatic ring, and then it attached to it yung OH. And then we have here you have this first group and another R group. Sabihin natin R1 and R2 yan. So, in the middle is your oxygen. So, this one is an ether. So, what is the importance nitong alcohols and phenols? So, alcohols and phenols are important solvents and synthesis intermediates. So, like for example, ethanol, your CH3CH2OH, is also called your ethyl alcohol. And ginagamit siyang solvent, fuel, and beverage. So bakit siya naging beverage? Yung mga mahilig uminom. So yung mga alcoholic na drinks natin, meron niyang ethanol content. Now, your phenol naman, it has a diverse uses, and it gives gives its name to general classes of organic compounds. So we can classify your alcohols based on the number of organic compounds that is bonded to the hydroxyl bearing carbon. So if this carbon, yeah, may OH dyan, that's the hydroxyl group, and then there is another uh, R group, so may carbon dito na naka-attach dito, so that is called a primary alcohol. Now, if you have two R groups now attached to the carbon wherein nakakabit yung OH, that is called a secondary alcohol. Now, if that carbon with the OH is attached to three different carbons, we call that your tertiary alcohol. So there is no such thing as the four or quaternary alcohols. UPAC name sim UPAC system names simple alcohols with derivatives of parent alkane with the suffix "ol". So yung ating mga alkanes ay yung suffix niya ay ini-end natin siya with an "ol". So i-drop natin yung E, like for example, you have your ethane. So alisin mo yung E, i-drop mo yung "ol". So I was saying na yung pag-name ng mga alcohols, ang ginagawa lang natin dyan ay yung parent alkane, yung pangalan ng parent alkane natin, drop natin yung E at pinapalitan natin siya ng "ol". So the suffix becomes "ol". Like for example nga, balikan natin, yung ethane mo, dahil meron kang naka-attach na OH doon, your ethane, you drop the E, you attach the "ol". So that's why it's called an ethanol. So how do we name alcohols? So we have three rules. So first is to select the longest carbon chain containing the hydroxyl group and derive the parent name by replacing E ending of the corresponding alkane with "ol". Lagi naman natin hinahanap yung parent chain. So lagi natin hinahanap yung parent chain at kung yun ay alkane, alisin natin yung E, palitan natin siya ng "ol". Now, the rule number 2 is we number the chain from the end nearer to the hydroxyl group. So kung pag nakita niyo yung OH, saan yung end na mas malapit? Ano yung end na mas malapit yung OH? So doon tayo magsisimula mag-number. And number 3, we always number the substituents according to the position on the chain, and we list them alphabetically. So let's give some examples. So this one, as we can see here, yung OH group is in this position. So kung mag-start tayo from kaliwa to kanan, we will encounter the OH group at the second position. Now, so ano nangyari doon? So meron na tayong idea na the OH is at the second carbon position. How many carbons are there in the parent chain? So we have 1, 2, 3, 4, 5. So that's a pen. So we know this is a pentanol. This is a pentane. Now, dahil may OH dito, we will drop that E and we will convert it to "ol". That's why the name is pentanol. Now, where is the OH? The 2 here before the pentanol, that will correspond kung nasaan yung hydroxyl group mo. So the hydroxyl group is at carbon position number 2. So ano na natin kung ano yung position niya. Now, we also have here a substituent. So the substituent here is a methyl group. So now, where is the methyl group? The methyl group is also at a carbon position number 2. That's why the name here is 2-methyl-2-pentanol. There's also a new accepted name. So the name is 2-methyl-pentan-2-ol. So ito kasing 2, nakakalito siya. Ano ibig sabihin ng 2 na yan? So yung 2, di ba sabi ko sa inyo, yun yung position ng OH group. So the OH group, doon sa new naming, naka-incorporate siya doon sa parent name. So the pentanol, nilalagay yung 2 in the middle. So pentan-2-ol. Next, we have here this one. So this one is a cyclohexane. Diba? The cyclohexane yan. So lahat naman ay single bond. So that's 1, 2, 3, 4, 5. Remember, it's a hexagon. But since it's a ring structure, so yan ay cyclo. So that's why it's a cyclohexane. Now, you will see, meron tayong dalawang OH. So ito ngayon, ang gagawin natin dyan, end pa rin natin siya sa ol. But this time, pag meron ng dalawang OH na nakalagay, that will become a diol. When you encounter terms like diol, that means dalawang OH. Pag triol, tatlo yung OH group. So, what will be the name? So, this one is cis 1,4 cyclohexane diol. So, napapansin nyo, yung lining niya, yung wedge, yung parang triangle, it's darkened. So, that means, pag ano siya, uh, yung OH groups mo ay on the same side nung ring. Kasi di ba uh, plain structure tong cyclohexane mo yan. Tapos nakaangat sila parehas. So parehas yung direction nila. So that's why it's called a cis. Now, where's the position of your alcohol, your OHs? So, sabi ko nga sa inyo, we can start with the numbering kung saan yung OH. So, this is 1, 2, 3, 4. So, that's why this is cis-1,4 cyclohexane diol. Next. So, this one is similar to the first example. So, again, we start the numbering with the OH dun sa pinakamalapit sa kanya, yung end. Now, where is the end na malapit? This part. So, we start here. So, this one is 1, 2, 3, 4. So, what is the parent chain here? So, 4 carbons long. So, that's a met and of bute. So, that's a butane. But we drop the E, we'll make it all. So, butanol. Now, where is the OH? The OH is at carbon position number 2. So, that's why it's called a 2-butanol. Now, we have another a substituent here, a phenyl group. So the phenyl group is at position number 3. That's why this is called a 3-phenyl 2-butanol. Ito naman, na-discuss ko na last time. So this one is an aromatic compound. So it's a benzene with a CH2OH. So this one is a benzyl alcohol. Okay. So ito naman, meron naman siyang kasamang alkene group. So may double bond. But the rule here is we start the OH kung saan yung end, yung mas malapit. So since this is the end, dito tayo magsimula mag-number. So this one is 1, 2, 3. So how many carbons are there in the parent chain? So 1, 2, 3. So that's met and prop. So that's why it's a propene. Propene siya kasi may double bond. Now, tanggalin natin yung propene yan, tanggalin natin yung E, gawin natin all. Kaya siya naging propenol. Okay? Propenol. Now, where is the OH? So, the number is 1. So, yung OH nakakabit siya sa carbon number 1. So, nakakabit yung OH doon sa carbon position number 1. So, that's why it's a propane 2-ol. Now, where is the double bond? The double bond is between 2 and 3. But since this is sa naming na may double bond, ginagamit lang natin kung saan nagsisimula. So, yung double bond starts at carbon position number 2. So, the name is 2-propene 2-ol. Next, we have here an OH group, but it is attached to a carbon that has three other carbons. So, ito ay isang example ng isang tertiary alcohol. So, this one is a tertiary alcohol. We'll just count the number of carbons there. So, 1, 2, 3, 4. So, met, et, prop, bute. So, this one is a butane. Pero, dahil siya ay naka-tertiary na configuration, so that's why it's called a terbutyl alcohol. Now, what is the name of this compound? So, again, we start the naming kung saan naka-attach yung OH. Sang end, mas malapit siya. So, mas malapit siya dito. Actually, either way. So, either way, malapit sila. So, yung OH is at position number 2. So, ano yung parent alkane natin dito? This is 1, 2, 3. So, met and prop. So, that's why this is a propane. Tanggalin natin yung E, gawing ol, propanol. Now, where is the OH? The OH is at position number 2. So, that's why this will become 2-propanol. Again, we have here a substituent, a methyl group. So, the methyl group is also attached to the carbon position number 2. So, that's why it will become 2-methyl 2-propanol. Next, we have here dalawang OH at the ends of your compound. So, ito ay diol kasi dalawang OH groups. Now, what is the parent name? So we have here 1, 2, dalawang carbon. So that's met-et. So that's ethane. So ethane, hindi na natin tatanggalin yung E. Pag dalawa na yung OH group, ikakabit na lang natin yung term na diol. So this one is an ethane. We have OH at the both ends, so that's why it will become ethane diol. But you need to locate where is the OH. So the OH groups are at carbon position number 1 and carbon position number 2. That's why the name is 1,2 ethane diol. Next, similar scenario with this one, but naging tatlo na yung carbons. So with 3 carbons, that's 1, 2, 3, met, et, prop. So that's why it's a propane. And since you have three OHs here, it will become a triol. So tri means tatlo and all tatlong OH groups. So it will become a triol. So the name is propane triol, but it doesn't end there because you need to locate where is the OH groups. So the OH groups are at 1, 2, 3. So 1, my OH group at carbon number 1, my OH group attached to carbon number 2, and then an OH group attached to the third carbon. So that's why the name is 1, 2, 3 propane triol. So here's just some examples of naming alcohols. So again, we start the naming at the end na mas malapit yung OH. So ito, mas malapit siya dito. That's why the naming is 1, 2, 3. 3. So meron tayong OH group at carbon position number 3. Ito yan. What is the name of the parent chain? So 1, 2, 3, 4, 5, 6. So we have 6 hexane. Since this is an alkane, tanggalin natin yung E, gawin natin all hexanol. So acknowledging that there's an OH group at the carbon position number 3, so it will become 3-hexanol. Now, we also have another substituent, a methyl group at position number 5. Kasi nga, establish natin yung direction ng yung direction of numbering because this end contains the OH. So that's why its name is 5-methyl-3-hexanol. Ito naman ay very straightforward siya kasi the name of the parent chain is 1, 2, 3, 4. So that's met, et, prop, but. So that's a but. Butane talaga siya, pero dahil may OH, we will drop the E, we will add the ol, so butanol. Now, where is the OH? So the OH is at position number 1. So this will become your 1-butanol. Okay. How about for 3 substituents? So we have here, again, you name the parent chain, and you locate the OH. So sa ang end, mas malapit yung OH. And since this end, mas malapit yung OH, this will be the direction of your numbering. So that's from your left to right. How many carbons are there in the parent chain? So the parent chain is 7 carbons long, so that's why it's a heptane. Heptane, we drop the E, we drop the E with the add the ol, so that will become a heptanol. Now, where is the OH group? So the OH group is at carbon position number 2, so that's why the name is hep2-heptanol. Now, we have 2 substituents pala dito. Dalawa lang pala, hindi siya pala tatlo. So, meron kang chloro and meron kang methyl. So, based on the alphabetization, your chloro will come first, then the methyl. Now, since you already established the direction of the numbering starting with this end kasi dito mas malapit yung OH, your chloro is at position number 4 and then the methyl group is at position number 6. And you know that chloro comes first than the methyl, so the naming is 4-chloro, 6-methyl, 2-heptanol. Okay. Next, this one is a case of a um, cycloalkane na may alcohol. So this one is your parent chain. So that's 6 carbon na naka-ring structure. So that's why it's a cyclohexane. Cyclohexane talaga siya. You drop the E, you replace it with ol, so that will become a cyclohexanol. Now, where is the OH? So dito, may OH and then may methyl. And we always start with the preferably yung OH ay nando sa end, di ba? So, ito, inassign siya na 1. So, dito, hindi na nilagay yung 1 cyclohexanol. So, understood na yun na pag dito, yung OH mo is at position number 1. Then, you decide what will be the direction. Is it counterclockwise or clockwise? Na mabibigyan natin itong methyl group ng mas bababang number. So, if we go clockwise, we will assign methyl with a number 2. But if you go counterclockwise, your methyl group will be at 1, 2, 3, 4, 5, 6. So 6. So 2 versus 6, you accept the lower number. So that's 2-methyl cyclohexanol. How about phenol? So ito naman ay napangalanan natin last time. So hindi ang ginagamit nating parent name is the phenol and not the benzene. And we always name the substituents on the aromatic ring by their position from the OH. Remember, there is a para, ortho, meta, para. So when you say ortho, that's just 1 and 2. Ortho, meta, meta means 1, 3, and para means 1, 4. So pag 1, 4, directly opposite sila. So like for this example, this is your benzene ring with the OH. So acknowledging that this imparts a special name, so this will become a phenol. Now, this is a phenol. Where is your methyl group? So your methyl group, if this is if this is position number 1, so the methyl group is at ilang ano siya, 3 carbons away siya. So that's 1, 3. That's why it's called the M-methyl phenol or just M-cresol. Okay? So this one naman is your acknowledging again that the parent chain, the parent name here is your phenol, and you have here two NO2 groups. So your NO2 group is named as nitro. Dahil dalawa yan, we name it dinitro. So, dinitro, where is the position of your nitro groups? So we have, this is 1, 2, 3, 4. So your nitro groups are at position number 2 and 4. So that's why the name is 2,4-dinitrophenol. So let's give a name for this compound. So ano yung mga makikita natin na pangalan, yung information na makikita natin? There's a phenyl group. There's a phenyl group. Phenyl group. There's an OH. And so may OH dyan at meron tayo isa pang substituent na methyl. Now, we will assign the name ng parent chain. We will assign the numbering doon sa end kung saan mas malapit yung OH. And since ito yung OH, dito tayo magsisimula numbering from your kanan to kaliwa. So, this is carbon 1, carbon 2, carbon 3, and carbon 4. So, anong mga ina-anticipate natin? So, this one is 1, 2, 3, 4. So, that's met et prop but. So, that's a butane. You drop the E, you make it all. So, that's why it will become a butanol. Now, where is the OH group? The OH group is at position number 2. So, that will become 2-butanol. Okay. Now, we have two apparent substituents here. One substituent is a methyl group and the other one is a phenyl. So, dito na tayo magde-decide which comes first based on the alphabetization. And based on the alphabetization, your methyl group will come first. Your methyl group will come first, then the phenyl. So where is the phenyl? Where is the methyl group? So the methyl group is at position number 2 apparently, and then the phenyl group is at position number 4. So we just assemble the name. So your methyl comes first, then followed by the phenyl, then the this one. So the name will become 2-methyl, 4-phenyl, 2-butanol. So let's check. So the parent chain must contain the hydroxyl group, and the hydroxyl group should receive the lowest possible number. And the name is 2-methyl, 4-phenyl, 2-butanol. So that's correct. So how about ethers? So yung ethers naman natin, the functional group is ROR. So it's also an organic derivative of water, having two organic groups bonded to the same oxygen atom. Remember, di ba, HOH. So we replace both the two H's here with an organic group. So we have here, paano natin siya nilaman? So we always end the name with a ether. Okay. And paano yung quick naming dito? We will assign the name for the substituent dun sa nakatouch kay oxygen. In this case, we have met, this one, CH3, CH2. So, ano lang dito is, we have 1, 2. So, you have two carbons here, and that corresponds to met, et. So, et. So, ito ay ethyl group. Ethyl group. Ito, ethyl group din siya. So, paano yung naming dito? Dahil pares lang naman sila na ethyl group. So, the name is diethyl ether. Okay? Next. This one, may oxygen ka, it's bonded to methyl, and then it's bonded to methyl, and there's a phenyl group. So, we know this is a phenyl group, and this is your methyl. So, the naming is methyl phenyl ether. Nauna dito yung mas maliit kaysa dun sa malaking substituent. So, this is methyl, then phenyl ether. This one is a special name because it appears to be a pentagon, so 5-membered ring siya, pero one corner of it is oxygen. So, in essence, meron kang, nasa na yung mouse ko, meron kang 4 na carbons here, and there's an oxygen. So, basically, this is still COC. So, this is still your ether group. Yun. So, the name is tetrahydrofuran. So, how do we name ethers? So, simple ethers are named by identifying two organic substituents by adding the word ether. Like yung example natin kanina, this one is your methyl, and then this one is your met-et-prop. This one is called your isopropyl substituent. So, it is named isopropyl methyl ether. Ito yung example natin kanina. This is the phenyl group, and ito naman yung inyong ethyl group. So, this will become your ethyl phenyl ether. Next. So, if other functional groups are present, the ether part is considered an alkoxy substituent. Next. So, ano yung mga example natin dito? So, ito naman is named as benzene. So, benzene talaga siya. Benzene. Pag naka-encounter kayo ng ganito, na CH3 na may oxygen, that is not a methyl group. That is called a methoxy group. So, CH3O. So, bakit nagkaroon tayo ng methoxy? Pag methoxy group, di ba, supposedly that's a methanol. But this time, your H is removed, so yung O, dapat may mabonding pa siya. So, yung O dyan is nakabond dito sa benzene ring natin. And we call this CH3O minus as the methoxy group. Since there are two methoxy groups here, we call it the dimethoxy benzene. And what is the position? Kasi directly opposite sila. So, this is called your para-dimethoxybenzene. Next. Medyo mahirap yung example na to kasi makita mo, meron kang ring structure na may alkene and there is an ether group here. So, how do we name this? So, this is named as 4-butoxy 1-cyclohexene. So, paano siya naging cyclohexene? This one is your cyclohexene part. So, bakit siya naging cyclohexene? Kasi meron kang 6-membered ring at meron kang presence of a double bond. So, your cyclohexane now will become cyclohexene. Now, where is the position of the double bond? So, di ba, natatandaan nyo sana na nag-name tayo ng double bond kung saan nag-start yung inyong double bond. So, we'll start here. This is 1, this is number 2, then this is number 3, and number 4. Now, what is this group? So, this one is met-et-prop-but. So, this is called your butoxy group. So, butoxy group, so that butoxy group is attached to that carbon position number 4 of the cyclohexene group. So, the name is 4-butoxy 1-cyclohexene. So, these are just some examples. So, we have here, yung kanina, that's diethyl ether. So, this time, we have a methyl groups on each side of the oxygen. So, that's called a dimethyl ether. Ito naman is there's a methyl group, and then there's an ethyl group. So, that's called an ethyl methyl ether. And ito yung same sila na ethyl groups at the both sides. So we call this your diethyl ether. So cyclic ethers can also be referred to their common names. So this one is called your ethylene oxide. This one is your tetrahydrofuran. And this one is your 1,4-dioxane. So we also name alcohols, especially if there are two OHs, we call them your diols. So dialcohols or diols contain two hydroxy groups in the same molecule. Mayroon kang dalawang OH groups at the same compound. So the IUPAC name of these alcohols are formed by attaching the ending diol to the alkane name. So you just determine the parent alkane name, and then you attach the diol. But in the process, you need to locate the OH groups. So this one is 1, 2, 3, 4. So you have four carbons here. So that makes it a butane. Then since you have OH groups na dalawa, so that's a diol. And you need to locate the position of the OH group. So yung OH groups mo ito, so dito nag-start siya sa dulo. So this one is your 1, 2, 3. So this OH here is at carbon position number 1, and this another OH is at position number 3. So that gives it a 1,3 butane diol. Next. So we have here an OH group, dalawang OH pa rin. So we need to determine the parent name. So the parent name is 1, 2, 3. So that makes it met and pro. So propane diol. Where is the OHs? So this one is considered the carbon position number 1. This is number 2. So your OH groups are at 1 and 2. So that's why it's 1, 2 propane diol. Now you also have another substituent that's a methyl group. So the methyl group is at position number 2. So that's why it's called a 2-methyl 1,2 propane diol. So ito naman, discuss ko na kanina to. This one is your ethylene glycol or that 1,2 ethane diol. This one is your 1,2 propane diol dahil mayroon ka ng tatlo. And then this one is your, how do we name this? So pangalanan natin siya na, we locate the parent chain. So this one is your 1, 2, 3, 4, 5, 6. So this one is your 6 hexane diol. So, hexane siya dahil may 6 carbons ka, and then may diol ka kasi dalawa yung OH groups mo. So, the OH groups are warp position. So, we have 1, 2, 3, 4. So, your OH groups are attached at carbon position number 2 and carbon position number 4. Then, we also have another substituent, a metal group at position number 5. So, that's why the name is 5-methyl 2,4-hexane diol. Hindi siya 2-methyl 3,5-hexane diol kasi ah ang lagi natin kinoconsider dito is anong end yung mas malapit yung OH. And the first OH that you will encounter is at this end. At this end. So dito nyo siya ma-encounter. Okay. So, going back, so for the naming of your alcohols or diols, so yung sa case dito, maaaring malito kayo kasi may dalawang OH. Saang end magsa-start. So the names will contain two numbers indicating the carbon bonded to two OH groups with the numberings starting at the end closest to one of the OH groups. So kung ito yung kinonsider natin, if this is the end, ito ay number 3. Pero ito kasi, pag ito yung kinonsider natin, um, yung OH group can be found at carbon number 2. So, i-accept natin yung mas mababang OH placement which is on carbon number 2. So, some properties of alcohols. So, your wag na to. So, this one. So, alcohols are polar. So, because of the electronegative oxygen, again, we have the CO, like for the alcohol nga natin. So, your oxygen is partially negative while your carbon is partially positive. So, dahil merong ganitong scenario dun sa C bond O, so your CO is polar. So hydrogen bonding occurs and has a strong influence on alcohol properties. So it can hydrogen bond. So next nating property is straight chain alcohols with 12 carbons are all liquid. So liquids ang straight chain alcohols natin. So methanol and ethanol are miscible with water. So when I say miscible, you can mix. You can mix methanol and ethanol with water. And methanol and ethanol can dissolve small amounts of ionic compounds. Both are also miscible with many organic solvents. So when we say this, ang ibig sabihin lang nito ay dahil your solute is organic, it can also be dissolved in an organic solvent. Just as long they have the same property. Kung dahil ang mga ito naman ay itong sabi ko nga sa inyo, yung alcohols ay polar. So polar yan, yung ano bang usual na ginagamit natin pag nagdi-dissolve tayo? Water. And water is also polar. So that means your alcohols can be dissolved uh, appreciably in water. So your water, um, another property is meron siyang part na water-loving or hydrophilic part and a water-fearing or the hydrophobic part. So you take note of the terms philic and phobic. When say phobic, phobia, so water-fearing. And then philic, it means loving. Ano yung water-loving part dito? The water-loving part is the OH group, while the water-fearing group is your hydrocarbon chains. So alcohols with larger hydrophobic part are more like alkanes and less like water. So imagine meron kang 10 carbon chain long na na tuloy-tuloy na carbons tapos may OH sa dulo. Yung 10 na carbons na yun, para siyang alkane. And yung OH dun sa dulo, yun yung parang attribute dun sa water. Pero mas malaki pa rin yung hydrocarbon chain. So, mas magmumukha siyang mag-a-act siya na parang alkane at less with water. Now, alcohols with two or more OH groups can form more than one hydrogen bonds. So they are therefore higher boiling and more water-soluble than similar alcohols with one OH groups. So ito yung sinasabi ko sa inyo kanina. This is heptanol. So heptanol, we have seven carbons. So this part is your water-fearing or the hydrophobic part and mukha siyang alkane. Ito namang may OH group is your water-loving part because of the OH. Okay, so hydrogen bonding can occur in alcohols and phenols. So assuming this is your R, the alkyl group or allyl group, so that we have OH, yung oxygen mole which is partially negative, will be attracted to uh, the partial positive nung another molecule. So this one is a molecule, ito another molecule yan. So magkakaroon sila ng uh, uh, intramolecular forces of attraction. So properties of alcohols and phenols, they are weakly basic and weakly acidic. So bakit? Kasi itong H na to, pwede yang gamitin na pwede yang ma-release. So pag nag-release ka ng H, pag dumataas ang H+, nagiging mas acidic siya. Ngayon, di ba ROH natin, yung ROH na yan, itong OH pwede din siyang maalis. So yung OH naman dito is yung magiging OH minus. This is your hydroxide ions. And pag tumataas ang hydroxide concentration, nagiging basic siya. So ibig sabihin ay mas bumababa yung pH. When you say acidic, mas tumataas. Again. Pag acidic, bumababa yung pH. Pero pag sinabi natin basic, tumataas yung pH. Kasi when you say basic, ang pH nito is yung 7 to 14. And when you say acidic, this is yung 1 to 6 point something, 99. Okay. So ito naman, weak acids. They are weak acids and they dissociate slightly in dilute aqueous solutions generating H3O+. So H3O+ is your hydronium ion So, pag tumataas tong H3O plus na to, nagiging acidic din siya. Okay? So, ano pa ang naging result nito? Meron kang dalawang alcohol molecules, they react with each other. So, itong water pala to. So, water ito, nag-react siya with the alcohol. So, yung H dun sa alcohol, nag-react siya with the H2O to produce your hydronium ion. Tapos, ano ang nangyari dun sa alcohol? Nawalan siya ng H. This is called your alkoxide ion. So, similar scenario with the phenol. Your phenol may OH dyan. The oxygen here will attack and will attack this H, so it will become an H3O plus, the hydronium ion. And anong nangyari dun sa iyong phenol? Yung phenol mo ay nawala ng H, we will call it a phenoxide ion. So, the strength of an acid in water can be expressed by an acidity constant called your Ka. So, Ka is just an expression. So, alam natin na your Ha reacts with water to produce H3O plus and the A minus. So, paano sinusulat ang Ka expressions? So, ang nasa taas dito is yung mga products. So, products siya all over the reactants. And sa reactants, hindi natin sinasamang water. So, the Ka is just the product of the concentration of the A minus times the H3O plus all over the concentration of your HA. And if we get the log of Ka, we will call it the pKa. So pKa is now equal to negative log of your Ka. So, ano yung mga indications natin? The smaller the Ka, mas malaki yung pKa. Ibig sabihin ng nun, less acidic. Pero kapag larger yung Ka, smaller yung pKa, it is more acidic. So, anong ibig sabihin lang nito, class? Kapag yung may acid ka at mas nagkakaroon ng tendency na makreate itong H2O+, ibig sabihin na convert totally yung acid into its H3O+ counterpart. So, ibig sabihin nun, mas acidic siya. Okay? So, mas acidic siya. So, nakukomplete yun. So, yung Ka value dito ay yung mas dumadami yung products mo kaysa doon sa reactants. Pero kapag yung substance mo ay weak acid siya, a small portion lang yung nakikreate na H2O plus and A minus. At mas madami pa rin yung HA. So, pag mas mataas ng HA, ano nangyayari sa Ka? Pag mataas pa rin yung concentration ng HA, bumababa yung Ka. So, pag pababa yung Ka, tataas ito sabi, smaller Ka, larger yung pKa. Kaya, less acidic. Okay? So, here are just some acidic constants of some alcohols and phenols. So, ang pinaka-acidic dito, less acidic is yung less acidic, larger Ka. So, this one is less acidic. Less acidic siya dahil mataas yung pKa. Ito naman, yung nitrophenol mo, ito yung more acidic. Yan. So, sabi dito, weaker acid siya going to stronger acid. So, last natin kailangan i-discuss is yung use ng phenol. So, yung phenol itself, formerly called carbolic acid, is a medical antiseptic that also numbs the skin. So, ginagamit ito noon sa mga operations. So, it was first used by Joseph Lister, who showed that the instance of post-operative infection dramatically decreased when phenol was used to cleanse the operating room and the patient's skin. So, ginagamit natin kasi ang phenol for cleaning. So, bumababa yung infection. So some other alkyl substituted phenols such as cresols or methyl phenols are commonly are common as disinfectants. So ginagamit sila as disinfectants. So ang phenols din can be used as antioxidant. So kapag madami ka noong yung phenol natin, di ba, alam natin ay may yung benzene ring na may OH. Pag madami kang aromatic compounds dito, pwede siyang gamitin as antioxidants. So, meron tayong mga terms like butylated hydroxytoluene and butylated hydroxyanisole. So, their abbreviations are PHT and PHA. So, foods that contain unsaturated fats, those having carbon-carbon double bonds, become rancid o nagiging balansa sila kapag yung oxygen from the air reacts with their double bonds. So, BHT and BHA will prevent the oxidation by donating a hydrogen atom from their OH group to the free radical as soon as it forms. So yung BHT and BHA, magbibigay sila ng H, madodonate nila yung H nila doon sa OH. Remember, ang ating alcohols, di ba, may O and H. So yung H dyan, pwede nating alisin yan. So that H can be donated, and dito, yung H yan, ibibigay niya doon sa free radical. So the BHA and the BHT is converted into a stable, unreacted free radical, which causes no damage. So vitamin E, a natural antioxidant within the body, acts similarly. So yung kaya nga issue din yung magte-take up pa ba ng vitamin E, naturally vitamin E is present in ample amounts of our uh, ample concentration. So, the more vitamin E that you introduce, may posibleng mag-react siya as pati yung ibang compounds ay i-reactan niya. So, the free radicals are suspected of playing a role in both cancer and aging of living tissues. So, sabi nga, kaya daw tumatanda ang isang tao kasi dumadami na yung free radicals. So, in order to uh, stop the aging or yung sa pagtaas niya in cancer, we need to use some antioxidants. So ito lang yung process. So this is the BHT. Ito yung free radical natin. It reacts with the BHT. So yung BHT dito, it will donate the H. It's H. Yung H na dyan, aalisin na sa BHT, i-donate dito sa free radical. So anong mangyayari? yung uh, yung unsaturated fat mo is protected from oxidation. So this is now, your BHT will become a stable free radical. Itong free radical na ito, sabi nga na ay, hindi siya, kahit free radical siya, hindi siya nag-react or hindi siya nag-cause ng damage. So that ends our discussion for alcohols, phenols, and ethers. Thank you very much.